Many organizations post geospatial datasets on the web that are frequently updated and hosted in a way that Python can extract them. Python can identify the links in the page. Then, using these data links, Python can download the data. This video provides a brief introduction to parsing using a package called BeautifulSoup. We'll look at an example that reformats the markup soup. We'll review terminology for the soup ingredients. And last, we'll parse a Google page with Python and extract all the hyperlinks in the page. Raleigh, North Carolina's farmers market has a wholesale pavilion. Before they banned it, people used to buy huge boxes of mangoes and then parse them out into piles of 6 mangoes and resell them to other customers right there on the spot. This is parsing. Fishing all the green beans out of your soup and putting them in your napkin is parsing. Finding all of the names of the images embedded in an HTML file is parsing. Getting a list of all the weather data zip files on a web page is parsing. There are a number of different modules for parsing markup languages in Python. We're going to use a popular one named BeautifulSoup. It comes as a package which requires installation, but there's also a Python script version that can simply be imported like other user-defined modules. You have a copy of this Python script version one in the GIS540 Chapter 20 sample scripts directory. BeautifulSoup.py contains a class, which is also called BeautifulSoup. We will be instantiating soup objects with this class and using them to parse markup language text. Soup objects have markup language related methods and properties. Some examples that we'll go over are the prettify method and the findAll method. This example shows how to use BeautifulSoup in a very simple way to prettify the soup. Prettifying is simply a method for reformatting the HTML so that it's readable, so it has carriage returns and indentations. Sometimes websites store the HTML without any spacing in it because they can and because the page loads faster. This is particularly true of JavaScript. That makes it really unreadable for humans, and so this prettify function returns it to a state where you can see all the indentation and new lines and much easier to read. In this example, we import the BeautifulSoup module in the first line. So this is assuming that the script we're looking at is in the same directory as the BeautifulSoup module so that we know that we can just import it there without appending to the system path. Then on the next line, it simply hard codes some HTML. These few lines have triple quotes around them so that we can keep the string going and wrapping around to another page. We've clipped off the script here. You can't see the entire HTML, but it goes on a little bit more. The main idea of this code is to show what prettify does. So in fact, this code takes the HTML string that we've created on line 4 and writes it to a file without doing anything to it prior, and then it prettifies the HTML and writes it out again. So line 9 is opening a file for writing, before.html, and we, on line 10, write the string to it and close the file. Then line 14 starts the new code to us. We've imported this BeautifulSoup module, and the BeautifulSoup module has the BeautifulSoup class. And you can pass into that class HTML response or an HTML string. And here we're returning a soup object from the class. So this is instantiating an instance of a soup object. Then we call the soup, there's a soup method called prettify. So we say soup.prettify, that's object.method right there. and it returns the reformatted HTML. Then we open the after.html file for writing and write out the prettified HTML. So here's what the HTML looked like in the before format, and here's how it looked after. That is, after the string was run through the prettify method. You can see that the BeautifulSoup method has parsed the elements of the HTML in some meaningful way, as it has indented them so that you can read. The body is inside of the HTML. HTML tag is on its own line. The body tag is on its own line. The contents of the header tag are on their own line. So there's a lot of intelligence going on in how it lays the format out. It's not just putting a carriage return after individual characters or individual elements. It's also, it knows something about the makeup of HTML, so it's parsing it out in a meaningful way. BeautifulSoup allows you to work with tag names, attribute values, and contents, so it's worthwhile to review this introductory HTML vocabulary. The tag names are those names that come inside of the angle braces, and start tags are the ones without the slash inside the tag. Attribute names are those attributes that come inside of the tags. The name is to the left of the equal sign, the value is to the right of the equal sign. And the contents is text that comes between opening and closing tag pairs. So that can be a mixture of text and tags, whatever is between the opening and closing tags. Take a moment to jot down your answers. Make 4 lists of these types of components that you find in the HTML in the box on the bottom of this slide. Pause the video now before we go on to the next slide and discuss the solutions. The start tag names that you'll find in this HTML code are IMG, A, BR, OL, and LI. Here's a list of attribute names. The IMG tag has src, alt, width, height. The A tag has href. BR does not have any attributes. The OL is using a type attribute, and the LIs are not using any attributes. The attribute values are the name of the GIF, the alternate text, the width specification 42 and height specification of 42. Then the href attribute is set to this link, so that's an attribute value. And then the OL tag has the type set to A, that makes it a lettered list instead of a numbered list. So that attribute value is A. Then the contents of the tags. Well, we have no contents in the IMG tag because it doesn't have a closing tag. It's only got the beginning tag. The hyperlink reference has text here, so that you'll see the text. It'll be probably underlined, and when you click on the text, it will browse to this. So the contents of the A tag are NCSG GIS because they come between the opening tag and the closing tag. BR does not have any contents because it doesn't have a partner. The OL tag, however, does have contents. So the OL tag starts here and the closing tag is here. That means everything that comes in between that is considered to be contents. So you can see that listed down here. Then the first LI tag has the contents of coffee, the second one tea, the third one milk. This example also shows you that you can either use single or double quotes for the attribute values. Here we've got single quotes around the A and double quotes around smiley.gif. Those could be reversed. Either way is fine. Next, we'll take a smaller selection of this HTML code, the ordered list section, and we're going to parse that with the BeautifulSoup module. BeautifulSoup has a method called findAll, which returns tag objects for all instances of the tag that you pass into the findAll method. So you take the soup object and call that findAll method with any tag name as a string, and it returns a list of tag objects, one for each of the li tags that it finds in the HTML soup. It will find all of whatever kind of tag you specify here in the input HTML soup. So this script uses the findAll method to get all of the li tags in a hard-coded HTML string. Here we're hard-coding the HTML. We're creating our soup object out of that HTML, and then we're calling the findAll method with the li tag, and it returns a list of tag objects. We note that this is our coffee, tea, and milk list, so there should be 3 li tag objects in there. Then we loop through those tag objects, print the tag object, the contents, and an empty line to space those out. First tag object that it gets is the beginning li tag with the contents and the ending li tag. The contents always are returned as a list, even if that list only contains one item. In this case, it contains the string coffee. Then we loop around again and we get to the tea tag object, and we have the contents of tea. We print that blank line, loop through again, and we get the last tag object. So if you called the soup.findAll with the OL tag on this HTML soup, you would get one tag object, the whole thing. The contents would be a list containing the contents that you see here. Tag objects also have a name property, which gives the name of the tag. You can use the findAll method with empty parentheses to return tag objects for all of the tags, as in this example where we've got the HTML that we used on the vocabulary page. We get the soup for that HTML, and then we call findAll with empty parentheses. That returns tag objects for every tag in this soup. Then we loop through. It's the same as the previous page, except we're printing the tag object names on this line instead of the contents. So the first tag that we have in this HTML is the img tag. So we'll have the whole img object printing out. That's what T is. And then the name should be img. We print an empty line, and then so forth. We go to the next one. We have this entire hyperlink tag, and we print the name. So that's what the output for this script is. So tag objects have these properties: contents, name, attrs, which stands for attributes. Let's look at an example that uses these two tags here. So if we have a tag object T1 for this image tag and a tag object T2 for this hyperlink tag, we can look at the name, attributes, and contents properties and see that T1.name gives us img, T2.name gives us a, attrs stands for attributes, and that returns a list of tuples with the attribute name in the first part of the tuple and the attribute value in the second part. SRC, angry tiff, alt, angry face, and so forth. This one is a list with only one tuple in it because there's only one attribute used here for this one, the second tag. It's href is the name of the attribute and the URL is the value. Contents property, we saw that on our first example. It contains a list of the contents between the opening and closing tags. Since T1 does not have a closing tag, it's self-closing, the contents are considered to be empty, so it returns an empty list. T2 has contents of NCSU GIS. So it returns a list containing that single string. Let's demonstrate some of this code in action. You can find similar code in the notes view of the slides. So I've saved it in GIS540 Scratch, and I also have copied BeautifulSoup from the chapter 20 sample scripts into the Scratch directory. I'm in PyScripter today, so I'm going to put my cursor on the first line and run to my cursor. Can use F8 to step over. And I've imported BeautifulSoup. It's jumped clear down to line 13 because all of this is to set the HTML variable to this string. Got that HTML variable. I'm going to step over line 16 to create that soup object. Type of soup. It's a BeautifulSoup class object. We step over line 17 and we get all of the tags. We're doing find all, so we're finding all of the tags in this HTML. Getting tag objects for each one. And this is a list. Python list. Starts with square brace, ends with a square brace. And if we loop through and use that set of tag objects, we're going to set T to the first tag object. And that's showing us that tag up here. If we say type T, it's a BeautifulSoup tag object data type. Go ahead and step over this line, which will print that tag object again. And then we'll print the name, t.name. That should give us img, because that's the name of that tag. Now we're going to loop through the attributes for this tag. We've got two variables here which we've named arbitrarily but with meaning. So this is going to be the name of the attribute, and this is going to take on the value of the attribute because t.attrs is going to return lists of tuples. Let's just take a little look at t.attrs. It's a list of tuples. So stepping over, attr is source, value is angry GIF. We can keep looping through here, and we're going to go through all of these attributes in this tag. Alt, width, height. That's the last attribute, so we're stepping back up out to our outer loop and going on to the next tag, which will be our hyperlink tag. So the name should be A, and this has one attribute set. The href attribute. Now before I go on, since this doesn't have any more attributes, and we're going to loop back up to line 19, I'm just going to say t.contents, show that that's the contents list of that one. And we can go on to the next tag object, which is BR. That one doesn't have any attributes, so we step right over that and clear on to the next tag, which is OL. Notice that that has all of those. We now say t.contents. It's a list of the contents within that tag. It parses out those pieces like that. And we're printing that name. And then we're going to go to the attributes list. This one does have an attribute set. Type set to A. And that was the last attribute, so now we're going to go on to the LI tags. As the tag object, name is LI, has no attributes. So T and milk. Now we have one more tag I've added in here. It's an image tag. That's how you can play with those tag object elements. Suppose we wanted to find all of the images that are linked to a page. I want to find the name of all of the images that are linked within an HTML page. So we can do that by using the tag that's appropriate for that. Here we're doing a soup.findAll with just the empty parentheses, but we can modify that to be looking at the image tag and run the code. We get all of these attributes for both of the two image tags that we have in here. If we want to really get just the names of the images that it's linking to, we can put a conditional statement in here. The name of the image is given in the source attribute. So if the attribute is source, then we want to get that. In this case, we just want the image name. We just want to only print out the names of the images. We could do this. We could be, say, appending those to a list. Say you have found a page that has hyperlink references to a set of data. So you have data sitting out on the web and you want to find all of these links on the page to data. How would you go about modifying this script to find those guys? I'll let you think about that. We'll come back to it in a moment. First, I want to say that so far in all the examples in this lecture, we've been looking at hard-coded HTML. Well, that's all fine and dandy for examples, but what you really want to do is be able to find HTML off the web or open a file and read it. Let's look at how to fetch HTML from the web. Before moving on to fetching HTML, there's code here on this slide to show how to look through those attributes. You want to use two variables inside of that loop between the for and in, because this returns tuples, which have the name and the value. We want to get away from hard-coded HTML. We need to be able to get HTML off the web. There's a built-in module called URLlib2, which is made for fetching web page content. And it has a URL open function, which returns a file object open for reading. So it's similar to the file object that you get when you call the open built-in function on a data set. So open in read mode. Pretty simple code. As long as you're dealing with text files like HTML, you can simply import URLlib2. You can point to the web page. This is a variable to hold the web page that we've got on GitHub for this example. And then you call the URL open method. So URLlib2.URLopen, and then pass in the string to your web page. And then it returns, calling it response, because it's a response from this call to URL open. It's a file object open for reading, so we can do something like for line in response.readLines, and that will loop through the lines that are returned, list of strings that is returned by this file object. Print that out. The contents of this web page are very simple. These are the lines that it finds. And note that we close it when we're done with it. Make sure you put those parentheses on there. If you forget the parentheses, you're not calling the close method. It'll just silently fail and it won't actually close that out. Yes, you can also use the with as format for this, but just to keep it simple, we've opened it and closed it. That's seeking out to the web. So now we can insert that into an example where we are parsing what we get back. This code takes google.com, gets a file object open for reading, and then inserts that into the BeautifulSoup class. So we're instantiating a soup object based on the response that we get. So we can send that directly in there. So we know that this can take a string. It can also take a file object open for reading. So we get that soup, and then the rest of the code looks very much like the code that we had in our demo. In this case, we are finding all of the A tags, that's the hyperlink tags. So we do a find all on that. We get all of those tag objects, and we're looping through those tag objects. We're calling them refs here because these are the hyperlink references. And we have a nested loop to loop through the attributes. And we're doing something like we did in our demo, checking for an attribute named href instead of an attribute named src. So this is the answer to the question that I posed a few minutes ago, which is how would you change that code so that you could find all of the links? And here it is. You use the A tags and then you checked for the href attribute. So here's a list of the hyperlinks on Google's page on the day that this was run. You can find this code in the comments section of this slide. If you try this code, you'll get a slightly different set of links. But it's kind of surprising how many links are in that page because it looks like it's pretty much blank. So you could do the same thing on a page that has lists of data sets linked to it. And we're going to do an example in another lecture. So this video covered generating readable HTML. That was the prettify method. Fetching HTML, that was URLlib2, and in general, parsing with BeautifulSoup.